Hi, very good morning. Welcome to the physics class. Today's class is related to the Kepler's laws of planetary motion. Today we have many advances in all walks of life in the field of transportation. So one can take aeroplane, which is one of the fastest mode of transportation. It takes from one point of the earth to the other point within 24 hours. We have submarines, which the vehicle which moves inside the ocean. So in the field of communication, so one can establish communication from one point of the earth to the other point of the earth within a fraction of a second using mobile phone. We have many space explorations, we have many satellites, etc. All these so much advances we have achieved by a method what we call as a scientific method. Question arises, what is scientific method? Observation, reason and experiment constitute the scientific method. Through scientific method, human beings have accumulated huge knowledge, and the huge knowledge was divided into various subjects like physics, chemistry, maths, etc. So in physics also we have various branches like mechanics, heat and thermodynamics, optics, modern physics, quantum mechanics, cosmology, etc. The list goes on, right? Question is, what was the beginning point of science? So nobody exactly knows the beginning point of science, but these ancient people got curious about the night sky. They started to observe the movement of planets with the background of stars, movement of moon with the background of stars. That was deemed to be the beginning of science, right? At the beginning time, there were many arguments among the people. So about whether the planets move around revolve around the sun or the sun revolve around the planet. But one of the scientists called Tycho had a different idea. So he went through more mathematically with a collection of data. So he took a telescope, focused the planets, so recorded the values of positions of the planet at the night sky at various times. He carried the experiment throughout his lifespan. He recorded all these in his data book, right? After his lifespan, one of the scientists, the Kepler, went through the data book, the data collected by Tycho. So he found that very remarkable observations. All these observations were recorded in terms of laws, were stated in terms of laws. All these laws are called the Kepler's laws of planetary motion. So there were three Kepler's laws. The Kepler's first law is related to the law of orbit. We will go one by one. What is Kepler's first law? Kepler's first law tells about how exactly a planet moves around the sun. So here is a curve. This is what we call as a ellipse. So ellipsis is not a oval. So this curve is more mathematically definable. The longer length axis, this is called major axis, and shorter length, this is called minor axis, right? So there were two imaginary points. These two imaginary points are called foci. So draw two tacks. Let's say this distance is A, this distance is B, okay? So let's say A is equal to 4 centimeter and B is equal to 6 centimeter, 6 plus 4 is equal to 10 centimeter. If somewhere the position of, consider a point somewhere here, if A happens to be 8 centimeter, then B happens to be 2 centimeter, such that A plus B should remain constant. If you join the end points, the curve obtained, this is what we call as ellipse. Right? So we have a mathematical equation which represents the ellipse. Consider such an ellipse. So with two foci, here is a ellipse, diagram of the ellipse. Here is a major axis, minor axis. There are two foci. Let the sun be at one of the foci. Sun does not shift its position from one foci to other foci, right? Every planet revolves, moves around the sun in elliptical orbit with sun at one of the foci. This is the statement of the Kepler's first law. Suppose if the length of major axis is equal to the minor axis, we will end up with a curve what we call as a circle. So circle is a special case of elliptical orbit. So what is the statement of Kepler's first law? Kepler's first law states that every planet, here is this represents the planet. So how exactly planet revolves around the sun? Every planet revolves around the sun in elliptical orbit with sun at one of the foci. Circular orbits are special case of elliptical orbit. So this law is also called the law of orbits. Now we will move on to Kepler's second law of planetary motion. So what is Kepler's second law? Consider the movement of a planet around the sun in elliptical orbit. So the position of the sun is somewhere written here. Let us start our observation at time t is equal to 0. This is the beginning point of our observation. Let the planet be somewhere here. This is the position of the initial position of the planet. Draw a line joining from sun to the planet. This line is called radius vector. This is called radius vector. When the time passes, planet moves on the orbit after 7 days. Let's say t is equal to 7 days. Let this be the new position of the planet. Now draw a new radius vector joining from sun to the planet. Now the planet moves over the orbit. This shaded area indicates the area swept out by the radius vector. Now this area is a physical quantity. Let us calculate the area swept by the radius vector in the span of 7 days. Let the area happens to be 100 units, some number, 100 units. Now, when the time passes, let the planet move over the orbit. After few months, consider, let this be the new position of the planet. So this is the beginning point of second set of observation. I write it as t dash is equal to 0. Again, when the time passes, the planet moves. After 7 days, let this be the new position of the planet. Let t dash is equal to 7 days. Same time interval we have considered. Now, draw a radius vector at a time t dash is equal to 0 and draw a new radius vector at a time t dash is equal to 7 days. Now, you calculate the area swept by the radius vector. If you calculate the area swept by the radius vector, the area happens to be same as that of the previous one. This a dash is also is equal to 100 units because the area has been calculated for the same time duration. So this observation was summarized in terms of the Kepler's second law. So what is that Kepler's second law? The radius vector joining the sun to the planet. Here is the radius vector. The radius vector joining from sun to the planet sweeps out equal areas in equal interval of time. The radius vector joining from sun to the planet sweeps out equal areas in equal interval of time. This is nothing but Kepler's second law. This is also called law of areas. Now we move on to understand the Kepler's third law. This is also called law of periods. What is a periodic motion? The motion which repeats itself after a definite time interval. That type of motion we call it as a periodic motion. After time period, what happens? The motion repeats. Now here is a consider sun. Let the sun be at one of the foci. The major axis, length of the major axis is always represented by 2a in ellipse. Half the length is taken from the junction to the end point here. The half the length is called a. This is called semi-major axis. 2a indicates somewhere here, end to end. Half the length is called semi-major axis. Also, the time taken by the planet in order to complete one full cycle, one full circular path, this is called time period, always represented by t. So now, the mathematical statement of the Kepler's third law of planetary motion is here t square is proportional to a cube. T represents the time period, a represents the semi-major axis, length of semi-major axis. Now the square of time period of a planet is directly proportional to cube of its semi-major axis. The square of time period of a planet is directly proportional to cube of its semi-major axis. This is the statement of Kepler's third law of planetary motion. Now, so there are three, let us summarize. So Kepler's laws of planetary motion, there are three laws. Kepler's first law is also called law of orbits. So every planet revolves around the sun in elliptical orbit with sun at one of the foci. Circular orbits are special case of elliptical orbit. The second law is called law of areas. So the radius vector joining from sun to the planet sweeps equal areas in equal interval of time, and the Kepler's third law is related to the law of, this is called law of periods. Law of periods means the square of the time period of the planet is directly proportional to cube of its semi-major axis. Thank you.